Hey there, awesome physics students. We want to talk about acceleration. So let's start with an example that we talked about previously. This is the example where you're sitting in a stoplight, it turns green, and then you begin to accelerate or speed up away from the stoplight from rest. And so your motion diagram, if you recall, looks like this. Your displacement keeps increasing even in equal time intervals. And the corresponding velocity time graph, position time graph looked like this, right? So your slope here increases over time. It gets steeper, and that is an indication that your velocity is getting steeper. And so our velocity time graph for this motion looks like, well, let's see how we would get this. Remember that the slope here is the value here. So here, this is a zero slope, so my value here is 0. Then the slope is positive, but very small. So and as you go here, the slope is positive and increasing. So my value here needs to become more positive and increase over time. Okay. So this is what the corresponding velocity time graph would look like for this. One thing, if you look at this in detail and plotted the velocity vectors between these points, they're going to look like this. So if we look at the motion in between these two points here, you notice that there's a change in velocity going from between these 2 points to these 2 points. So let's call this point, the velocity vector here, v initial, and we'll call this one v final. And we can think about what does the change in velocity between those 2 points look like. So the change in velocity, of course, is going to be v final minus v initial. And remember, these are vectors. So what we need to do is take v initial and make it negative, so flip it, and then put it tip to tail. So this is negative v initial. And our resultant, delta v, which is also a vector, goes from where you start to where you finish. So this is the delta v, or the change in velocity. We don't have a nice name like, change in position gets its own name, displacement. We don't have a nice name for change in velocity. It's just called the change in velocity. Okay? So one can then think about what is the change in velocity over time. And this is what we call the acceleration. And it, too, is a vector. It gets its vectorness from the change in velocity vector. Okay, so one main thing to remember here is that the acceleration vector will always point in the same direction as the change in velocity. Okay, I'm going to repeat that in some other videos here. So how could we get acceleration from this graph here? Well, because we're looking at the change in velocity over the change in time, remember the change in velocity, if we pick 2 points here, that's going to be the increase here. So this is the change in velocity, which is the rise, and the change in time is going to be the run. And so this is rise over run. That means that acceleration is going to be the slope of the velocity time graph. So let me just write that out. Acceleration is the slope of the velocity time graph. Okay? Okay, so again, we're having this symmetry here where we have to take the slope here is the value here. So the slope here is positive and constant. Therefore, the value here must be positive and constant. Okay? So that is the corresponding acceleration time graph to this velocity time graph. All right? And that's acceleration.